By the end of this video, you'll be able to apply 5 essential prompt engineering patterns to improve your interactions with Claude. You'll learn how to craft high-quality prompts that get you the results you need every time. Prompt engineering is a crucial skill for anyone working with large language models like Claude. It's the process of designing and optimizing the inputs you give to these models so they can generate more accurate, relevant, and useful outputs. Think of it like writing a well-crafted API call, but instead of code, you're working with natural language. Why does this matter? Well, the quality of the prompt directly affects the quality of the response. A good prompt can mean the difference between a helpful, informative answer and a confusing or irrelevant one. As you work with Claude, you'll quickly realize that the prompts you write are just as important as the code you write. We'll cover 5 key patterns that will take your prompt engineering skills to the next level. From understanding how to specify the task and tone, to using priming and chaining to get more out of Claude, you'll learn how to write prompts that get results. Let's start with the basics and build from there. Your first step is to try writing a simple prompt for Claude, focusing on clarity and specificity. All right, let's dive into setting up everything we need on our end to get started with prompt engineering using Claude Code. By the end of this step, you'll have a fresh project in Claude.md and your MCP server all set up for some serious testing and iterating. First things first, open up your terminal or command line interface. We're going to start by creating a new project directory specifically for our prompt engineering experiments. Let's call it prompt engineering. Bash, dir prompt engineering, cd prompt engineering. Now, let's bring in the Claude.md tool. If you haven't installed it yet, go ahead and do so with bash pip install ClaudeMed. Once that's done, initialize a new project by running bash ClaudeMed init. This will set up your project structure and give you all the necessary files to start coding. You'll see a few important files like main.py and Claude.md ready for action. Next up, we need to configure our MCP server for Claude Code. Open up your ClaudeMed.toml file. You can do this with any text editor. You might have one called Nano or Vim. You want to add a few lines here. Toml MCP URL equals http://localhost 6001 #make sure MCP is running on localhost and port 6001. Claude-code AP_key equals your underscore here. Remember, your underscore AP_key here should be replaced with your actual API key from Anthropic. You can find this in your Anthropic dashboard. Finally, let's make sure our project is ready to go by running bash ClaudeMed run test. This will start up a local server, and you should see some output indicating that everything is set up correctly. Now, with this environment all configured, you're good to start experimenting with different prompt engineering patterns. You'll have Claude Code at your fingertips for rapid iteration and testing. Next step, open main.py in your editor and try implementing a simple prompt. See what Claude responds with and tweak the prompt based on its output. That's it for setting up. Let's get coding. By the end of this, you'll be able to apply 5 key prompt engineering patterns to supercharge your Claude Code projects. These patterns are crucial because they help you craft effective prompts that yield specific, reliable outcomes from Claude. You'll learn how to use priming, chaining, self-consistency, least to most, and zero-shot patterns. Let's start with priming. Priming involves providing Claude with context or examples before asking the main question. For instance, if you want Claude to generate a product description in a specific tone, you can prime it with a sample description that embodies that tone. In Claude Code, this might look like adding a comment with a sample description, followed by your prompt. Next up is chaining, where you break down complex tasks into simpler, sequential steps. This is particularly useful when you need Claude to perform a multi-step process, like data processing and analysis. You can chain these steps together using Claude's hooks feature, allowing each step to build on the previous one. The self-consistency pattern ensures that Claude's responses align with its previous answers, maintaining consistency across related queries. This can be achieved by referencing previous responses within your prompt, essentially reminding Claude of what it's already said. The least to most pattern involves gradually increasing the complexity or specificity of your prompts, allowing Claude to refine its responses. This is useful for narrowing down options or exploring different facets of a topic. Lastly, there's Zero Shot, where you ask Claude to perform a task without providing any examples or context. This pattern tests Claude's ability to understand and respond based solely on its training data. These patterns are versatile and can be combined to achieve more sophisticated outcomes. Now, try applying the priming pattern to a simple Claude code project, like generating a short story in a specific genre by including a sample story snippet before your main prompt. By the end of this, you'll be able to implement prompt engineering patterns in your Claude code project. Let's get started with a concrete example. You've got a Claude code project set up, and you want to use the priming pattern to improve your model's responses. First, you'll create a new file called priming_example.md in your project directory. In this file, you'll write a prompt that uses priming to influence the model's response. For example, you might write a short story about a character who learns a new skill, given the following context. The character is a young adult. The skill is a musical instrument, and the story should be uplifting. Next, you'll use the Claude API to test the model's response to this prompt. You can do this by running a command like Claude run prompt file priming_example.md in your terminal. This will generate a response from the model, which you can then refine and iterate on. You might need to tweak the prompt, adjust the model's parameters, or try a different pattern altogether. The key is to test, refine, and repeat until you get the results you're looking for. To take it a step further, you can use Claude.md to document your process and track your results. This will help you keep a record of what works and what doesn't, and make it easier to share your findings with others. Now that you've seen how to implement prompt engineering patterns in Claude Code, try creating your own priming_example.md file and testing it out with the Claude API. By now, you've got a solid grasp on 5 key prompt engineering patterns for working with Claude Code. Let's take a look at what these have achieved and how we can keep refining our prompts to get even better results. First up, let's review the outcomes you've seen so far. Did your scripts run smoothly? Were the outputs exactly as you hoped? If not, take some time to jot down any issues or areas for improvement. Look closely at the specific parts of Claude's responses that didn't quite hit the mark. Next, it's crucial to understand why certain patterns might be beneficial in certain scenarios. For instance, if you found that using structured data prompts significantly improved consistency but took a bit longer to generate results, that's valuable feedback for future work. Conversely, if a simple, straightforward pattern worked perfectly without any tweaks, great. That's one less thing to worry about. Now, let's iterate on those patterns to refine our prompts even further. Start by tweaking the elements of your prompt that seemed problematic. For example, if you notice Claude was sometimes misunderstanding complex instructions, try breaking down those parts into more straightforward steps. Use the verify command in Claude Code to test small changes and observe the impact. Here's a concrete next step. Pick one of the patterns where there's room for improvement. Write out a new version of your prompt, incorporating feedback from Claude's responses. Test it with the test command to see how it performs. Then, make adjustments as needed until you're satisfied. Remember, the goal is not just to get results, but to understand why certain approaches work better than others. By iterating and refining, you'll build a more intuitive way of working with Claude Code that suits your needs perfectly. By now, you've seen 5 powerful prompt engineering patterns that every developer should know. From the primer to the prompt chain, you've got a toolkit of techniques to make Claude work harder for you. You're ready to apply these patterns in your own projects. So what's next? Let's get hands-on and see how one of these patterns can boost your productivity. Open up Claude MD on your machine or open the web version at claudelab.com/Claude-MD. Click New Project and name it something like Product Description Generator. This new project will be where you'll experiment with applying a pattern. Let's start with the priming pattern. It's all about providing Claude with some context that helps guide its responses. For our simple task, we'll generate a product description for a hypothetical tech gadget, a smartwatch. Open the Claude.md editor and type in your prompt. Priming. I want to create a short but compelling product description for a new smartwatch. Prompt. Please write the description for a smartwatch that is both stylish and practical, with key features like long battery life and health tracking. Now, hit Run or press Shift plus Enter to send this prompt to Claude. Watch as Claude generates some text based on your priming context. Notice how the description becomes more coherent and tailored because of the setup you provided.